Hey everybody, welcome back to the channel. So today we're going to continue with our final exam review, and this time we're going to look at the Principles of Math 11 or Pre-Calculus 11 or part of Algebra 2. But if you're in BC, the course is called Pre-Calculus 11. All right, so we're going to deal with the review of quadratic function. And this first question or review, it's about analyzing a quadratic function and find all the characteristics of the function. And that means what I've done, I have actually listed all the necessary and important information that you can extrapolate from a given quadratic function. Now, this equation or the function is given to you, but it turns out that the way it's set up, and I did it on purpose, so that you have to do a lot to this to get all this information out of this equation. So first, notice that this is the general form. You have to change the general form to a vertex form or standard form, and we have to go through that to do that. And then once we have that, we can extrapolate all the information, important information about the function, and we're going to list them one at a time. First thing first, the changing that to from the general form to standard form. And remember, the standard form, it will look like this: y equals to a x minus p all squared plus q. All right, now it could be plus or minus q, where p and q, that's the vertex. So where p and q is the vertex of the parabola or the quadratic function. So that's what we're going to do. And to do that, we're going to use what is called as completing the square method. So that's, remember, that's a review. And I will post the review. So what I will do, I will post a link somewhere in the video on the channel where you can click on it and go back and review how to do the completing square method. Okay. All right. So first thing that we're going to do, we're going to do the completing square method. So the first thing, we're going to factor the -2 out of the highest term, the leading coefficient x squared. That's what we're going to do first. And we're going to leave everything else alone. Okay, so I just factored -2 out, and what I have is x squared plus 2x. Okay, now to complete this square, this is what we need to do. Leave the -2 alone, and now we're going to take the middle term, which is right here. 2 is the coefficient of the middle term. Well, it's the second term, but coefficient of the x, not the x squared, the 2. We take that, we take half of that, so that's 2 divided by 2. So we get 2 divided by 2, and then we're going to square that, and we're going to add that 2 inside of that bracket. So that becomes plus 2x, again, plus 1, okay? We can't just add a value to this equation because that's not illegal. So whatever we do, we have to neutralize that. That means we can add 0 to one side, but we cannot add a number or subtract a number just randomly, because that's not allowed. It's an equation. Whatever we do to one side, we have to do the other side, or we can just add 0 to one side. So in this case, notice that what we've added, we actually added -2. You can say subtract -2, but it doesn't really matter. So we need to undo this. So to undo that or neutralize that, we're going to add 2 to it. Okay, so now we're going to go back and rewrite. Now at this time, notice that we have not done anything illegal. Whatever we did to one side, we did it to other side, but in this context, we just basically added 0 to the right-hand side. Okay, so what do we have? We have y equals -2, close the bracket. Now, this trinomial right there, that's a perfect square trinomial. So that trinomial is actually x plus 1 all squared. When you factor that, that's what you're going to get. Okay, and then plus 2, Excellent. So now you notice that we have this vertex form. And what is the vertex? So this is the standard form or vertex form. Okay, what is the vertex? So now we can go ahead and really answer all the questions that we have, all the characteristics of this function, and we're going to go through one value, one characteristic at a time. Okay, vertex is very easy. Vertex is -1 and 2. So remember, whatever you see x plus 1, whatever you see this value, this is plus 1, the actual vertex is opposite of what this value is. If it's plus 1, the x coordinate of the vertex will be -1. And then, but the y coordinate stays the same. That's +2 and that's +2. So that's the vertex. Okay. Now, number 2, the maximum minimum value of the function. Well, a couple of things. Notice that there is a negative in front here, right? The leading coefficient is negative. That means the graph is upside down. Okay, I have to answer the second question, which is says maximum minimum value of the function. All right, first notice that this equation has a negative value in front of the leading coefficient is -2. That negative, that means the graph is upside down. So I'm going to put it in a quotation. Okay, that's the negative sign, means the graph is upside down like that. And if it's upside down, that means the maximum value of the function, it has a maximum because the graph is seals off, right? There's a maximum, is going to drop off. The graph does not go further up, right? And we don't know exactly where it is on the coordinate system, but we know that it's dropping down. That means it has a maximum value. Okay, if this has a maximum value, the maximum value is the y coordinate of the vertex. So the maximum value is, so that's what the maximum value of the function is. All right, now next one, we're going to go back, X-intercept, Y-intercept, and axis of symmetry. Now, we should know axis of symmetry right away. So let's do axis of symmetry. So I'm going to put in there 3 and 4. So axis of symmetry is actually an equation, and that basically goes through the x coordinate of the vertex, and we know that. So set x plus 1 equal to 0, and then you solve for x, and that's x equal to -1 is the vertical line that basically makes the graph symmetric. Okay, so this is the x equal to -1. Okay, all right. Now the next part is the X-intercepts. So the next intercept, the X-intercepts, is just very easy. We can use the original, the general form. We just solve for x when y equal to 0, because that's what the X-intercept is. So let's move the 3 down. So I'm going to erase that. So let's do the 3 down here. So X-intercept, and then we'll deal with the y-intercept. Okay, so we're going to set the function equal to 0, because for x-intercept, y is 0. So minus 2x squared minus 4 equal to 0, or 4x equal to 0. So to do this, is simply we're going to factor negative 2x out. And what do we get? We get x plus 2. Here, x either equal to 0 or x equals to -2. Perfect. We got 2 x-intercepts, and these are it. These are your 2 x-intercepts. Now, what would be your y-intercept? Okay, let's deal with the y-intercept. But notice that when x's are 0, these are basically, we have to set x now equal to 0 to get the y-intercept. And when you put the x equal to 0, you notice that you just get 0 squared times -2 minus 4 times 0. So the entire right-hand side here would be 0, so y equal to 0. So basically, we have y one y-intercepts. Okay, so here it is, the y-intercept. We set x equal to 0. We put it back into the original equation, which is right here, and then we get y equal to 0. Remember, for x-intercept, we set y equal to 0. Okay, so that's what we're going to do. And the last piece that the question is asking, domain and range and orientation of the graph. Now, we already answered the orientation of the graph. The graph is upside down. Okay, we've done that right here because it's the negative leading coefficient. Okay, and in this case, A, so when A is negative, let me write a note here. So here it is. If A is negative, then the graph is upside down. If A is positive, the graph is upside, right side up. Okay, so that's the review for that. Now the last thing is domain and range. Domain and range is very simple because you see the graph as a maximum, so you know that the domain is all real number because the graph is going both sides, to the left and to the right of the x-axis forever. Okay, so all real set of all real numbers. Let's go back. All right, so the last piece, number 5, domain x belongs to all real number, okay? But the range has got a maximum, and the maximum value of the range was 2, okay? So the way you write it, I'm going to write it in a proper way. So this would be the proper write it as a set. So it would be y such that y has to be less than equal to 2. I just want to double check that I got that right. Yes, I do. The maximum value of y is 2. And then comma, y belongs to all real number. Okay, and then all real number, this is the real number set. That means everything except the complex numbers, right? Rationals, decimals, whatever you got in between, integrals, all of that, or integers. Okay, that's the last piece, and we're done now. You could technically graph this, and it could be the final answer or final question for this. So you could be asked to graph this. Okay, so if you have to do that, then you have to graph it, and let's do a quick graph. Here it is. Okay, so now I have this grid right here, and we put in the vertex coordinates -1 and 2 for the vertex of the function. We know the x-intercepts and the 2. One is -2, the other one's 0. And now that we have that, we're just gonna graph that. Now, we could make it really accurate and come up with a couple of more points by plugging values in there. Now, I do suggest you choose a couple of more. Now, I do suggest that you choose a couple of more points to make sure somewhere in between -2 and -1 and -1 and 0, halfway in between or something like that, and then make sure you get the value x, plug it back into the original equation, get some values with your using calculator or something like that, and then you have another point right here, another point right there, and then you can actually plot them. It's reasonably accurate because it's freestyle. Obviously, it's not going to be 100% accurate, but that's what it will be. Okay, I hope you found this useful. Okay, so remember that when you're doing a review of final exam, you do need to go through each of the units, right? So you take out the unit test, quizzes, the projects that you did for that specific unit, and then you review. Okay, you go through each of the questions, and if you get stuck, you forgot about the concept, what do? You have to go back to the notes and make sure that you refresh your memory. All right, now the earlier time that you started, so let's say you took it in semesters to second semester, let's say you are in semester system, not a year system. If you're a year system, so that means you have to go back to the September notes, right? That's way back. You probably forgotten a few things, but that's okay. Don't fret, okay? You go back and you do that systematically. Chapter 1, Chapter 2, Chapter 3, whichever, however sequence your teacher have taught or gone through the course, you follow that. All right. But remember, methodically, what you need to do, and there's no easy way out of here, okay? Not going to sugarcoat it for you. You got to do the work if you want to do well. So you got to review the questions and then listen to your teachers when they go through the review for final exams, because the chances are some of the questions that they're going to put on the board or they go over, the chances are one of those or some of those questions going to show up exactly. That's pretty much I used to do. Okay, hope you found this useful. Practice, practice, practice. Come back again for more review questions. Have a fantastic day. Bye.